Now this is an extreme exaggeration, but if your engraving comes out almost shadowy or double image, chances are your offsets are off. And just to be clear, a double image doesn't just mean it's offsets. It could also mean a loose lens or loose mirror somewhere around jiggling as the gantry is moving. So make sure all of those are tightened first, and then we can assess if it's actually offsets. First, let's go over some offset theory. Imagine we just engraved a square, but the square, the left and right sides look a little bit fuzzy. Let's take a closer look. Okay, so this is supposed to be a magnifying glass, but anyway, offsets control when the laser starts, turns on, fires, and then turns off. Now, if we wanted to just engrave from left to right, which is normally the default for most gantry style lasers, left to right, then that's fine. We turn on, turn off, and then the machine moves all the way back over here, turn on, turn off. However, that would take substantially more time than just turning it on down here and moving back over from right to left, instead of just doing left to right all day. So we go into Lightburn and enable bidirectional fill. That's now gonna enable us to turn on our laser from right to left, which is going to be that way. Now you might notice that my lines don't perfectly match up. They're staggered, right? Now this is what happens in a real world scenario without offsets enabled or offsets that need to be adjusted. So say I'm engraving this square at 1,000 millimeters per second. Cool, the gantry speeds up, it's at 1,000 millimeters per second, and then boom, it hits my end mark, and then it has to slow down and then quickly turn around as quickly as possible, and then also go 1,000 millimeters per second. Acceleration, deceleration, all of that back and forth on a pulley and belt system, there's gonna be some mechanical lag. So that's why there's gonna be this offset. And this line shift, or the staggeredness of the lines, is gonna be a lot more prominent at higher speeds than it will be at lower speeds, just because the gantry doesn't have to move back and forth so quickly. Now luckily, Lightburn has a feature where you can enter an offset to get rid of this little distance in between those lines, called our line shift. That means if I enter an offset in, that's not just gonna affect my right to left, it's gonna affect my left to right line as well. They're both going to shift at the same time. Now that can be troublesome if you just enter numbers and everything moves around. Just remember that that space, that offset that you put in for your line shift, is gonna affect both lines. So here's an example of everything covered in that theory. This one is engraved with offsets enabled and tuned. And if you can look really closely at the edges, everything looks smooth. You don't have any jagged edges. Now this is extreme, but this is with offsets not enabled at all. So you can see the double image of the engraving from left to right and right to left. They both have their different start times and end times, so everything looks doubled or shifted. That severely needs offsets adjusted, or just turn them on and you'll be good. This is with offsets needing adjustment. Now you can tell the difference. There is a little slight shadow on the edges of the letters, and that is exactly what we're trying to combat. Then two more examples, usually more prominent on the tumblers. You can see on the edges, it looks like steps. It's not a solid diagonal line, they're jagged, they're step-like, compared to something with much smoother edges that look much more natural than the staircase jagged diagonal lines. That is the difference between good offsets and then offsets that need to be adjusted. The machine we'll be using today is going to be our Razor Duo, which has the dual sources, glass tube and RF, in case we want to swap over to the RF with a much smaller dot size and get really fine engravings. The method I'm about to show you works with either offsets already on your computer that you just want to adjust, or no offsets at all, and we're going to start from fresh. To even get to offsets in Lightburn, you want to navigate up to the top and click your device settings. That's going to be the wrench and screwdriver icon. It's going to be under basic settings and right down in the bottom left hand corner. Now I'm doing this in Lightburn 1.7.03, Lightburn 2.0 and beyond. It looks a little bit different with the ability to put in an offset for two lasers, so that works perfectly for a machine like us with those two laser sources that need different offsets, because one fires a whole lot faster than the other. So like I said before, I work better when there aren't any offsets at all and I can set it up however I want. So I'm gonna go ahead and delete my current existing offsets, and we're gonna start from fresh. We're gonna go ahead and exit out of this, and I'm gonna make a little square. We're gonna make sure that square is in fill mode. We're gonna go into that layer. We're gonna go in and change the line interval to something like 0.5. That's gonna increase our our spacing between lines significantly, so it just makes the measurements a whole lot easier to take. So now I'm gonna run this on a 130 watt glass tube, so adjust your power accordingly, but the speed that you're gonna be putting in is gonna be the speed for the offset that you're gonna want to adjust. Now, if you have an existing offset, say 600, we're gonna put 600 in, take measurements and adjust that. But if you don't have an offset, select whatever speed you most commonly do for whatever engraving or work that you do. For example, a lot of people engrave tumbler cups, and those tumbler cups are usually run at 550 millimeters per second. For someone wanting to fine tune that exact speed, you're gonna be putting in 550 millimeters per second. Now let's say I do a lot of engravings on this specific type of wood at 300 millimeters per second. Since I do that speed so commonly, I'm gonna wanna adjust my offset specifically at that speed. We throw in 300. All right, let's go ahead and frame and engrave. Perfect. Now that it's done engraving, what we're gonna wanna do is specifically look at those lines. Look, they are staggered like what we covered in our theory. Perfect, that's what we want. Sorry, another illustration, but there will be a much prettier version of what I'm gonna cover down in the description on a downloadable PDF. Okay, so this is the gist of everything to do with offsets. Now, either you have to adjust your offsets because there's a staggered line, or we just shut them off completely or deleted them and we're starting from new. Now, what I just did right here, there are some staggered lines. All we're looking at is the first top two staggered lines, and it's gonna look something like this. Now, those top two staggered lines, either the top one is going to be way off to the right, or it's gonna be covering the bottom line like this. It's either gonna be a roof or it's gonna be a stair step, right? Now, in my case, since I turned the offsets off, it's gonna be a little stair step, and I'll draw a much bigger example here. This is what my first top two lines look like. So since my top two lines look like a stair step, right? The top line is off to the right, bottom line is off to the left. That closely resembles this, my stair step, not my roof where the top line is over on the left-hand side. So what we're gonna wanna do is add. Now keep that in the back of your head. We're gonna go down here to our equation. It's gonna be y plus or minus x divided by 2, and that's gonna be our new line shift. Now, y is gonna be the existing line shift, so for those of you who have an existing offset you want to adjust, this is where that comes into hand. It might be 1 point blah, blah, blah. We're gonna either add up here if it looks like the stair step, or subtract if it looks like the roof. Add or subtract x divided by 2. X is gonna be that measured distance. So we're gonna get some calipers or a really small ruler and measure that distance. We're looking at the horizontal distance from here to there. That measurement we're gonna divide by 2 and either add stair step or subtract roof, and that will be our new line shift that we'll enter into Lightburn, and then we'll redo our results and see what we get. Okay, so my X is going to be 2.29 millimeters. Now looking at our equation, our Y is going to be 0 because I deleted our offsets. Plus, right, because I have to add, my top two lines look like a staircase. We're going to add 2.29 divided by 2. Divided by 2. I had to throw that in the calculator real quick, which is going to be 1.145 millimeters to a grand total of, well, that plus 0 is just going to be our 1.145 millimeter offset. Let's go ahead and plug this into Lightburn and then redo that same exact test right next to it and compare the difference. Now, if you're unfamiliar with inputting offsets into Lightburn, let's walk through it. We're gonna go, once again, device settings up at the top, basic settings, and then our bottom left-hand corner. Now, I did it without offsets in there, so just make sure that enable scanning offset adjustment is on for when we test it again. We're gonna come down here to add. This is how we add it in. Now, I just did my offset test at 300 millimeters per second because that's what I'm gonna be running most of my stuff at. So let's go ahead and put 300 in, and then my line shift is what we calculated to be 1.145. We're gonna hit okay, awesome. And if I want this offset in another machine, so more so if you have like 5 different offsets, all you have to do is hit export. It's going to save it as a Lightburn offset file, and then you can import it into your other computer without having to retype all those numbers over and over again if you have a bunch of them. We'll hit OK, and then let's go ahead and redo that test. Oh yeah, okay, so that looks significantly better all the way from over here. Cool, so we reran that test, and if you look really closely, you can see that it's still a little bit off, and the reason being, I did that out of focus. Make sure you are in focus, but since we were out of focus originally, our number is going to be a little bit off. So now I can go through what would happen if you did the measurement and it wasn't correct, or it still has jagged lines. How would you adjust that? We're going to do the same exact thing, and then we're going to go into the offsets again and just change that number. And that's the whole process of just adjusting from existing offsets. Now we're going to do the same exact thing we did before. However, this is why I usually opt to turn my offsets off or just completely get rid of them, because these lines are significantly harder to line up or see. And of course, you could also increase your spacing between each line. It doesn't, I just use 0.5 line interval as an example. You can make that much bigger if needed. But now I'm going to try and do my best of measure this X, my horizontal line, which is going to be about 0.7 millimeters. So just like we had before, my X is going to be 0.73 millimeters. Cool. So we're going to use our Y. Our Y is going to be 1.145, and we're going to look at those top two lines. Now we're going to want to look at our little handy dandy chart. Is this a roof, or a staircase? And it's actually a roof. The top line is going to be overhanging far over to the left, so we're going to want to subtract. So it's going to be 1.145 minus 0.73 divided by 2, which is going to be 365. Total of 0.78. With it back in, let's go ahead and adjust the offsets. We're going to go back into device settings. We're going to go down to the bottom to that 300 that we just did, 300, 1.149 or 5. We know that that's a little bit too big. We're going to decrease it to 0.78 and hit OK. And that's all it takes to just adjust your offsets. That easy. We're going to go ahead and frame and then redo the line. And then this is where the scary part happens. It gets really hard to tell. Once the lines are right on top of each other, it's really hard to tell if they're off at all or if your eyes are just playing tricks on you. So this up to user discretion. You can keep trying to go back and forth and adjust it even more if need be, but I mean, once it's right on top of each other, that's pretty good. So just an overall recap, we started out with lines looking like that with no offsets, right? And then we ended up with something like this, where the lines are right on top of each other, and that looks like a pretty good offset, all from that little equation of y plus or minus x divided by 2, and that'd be your new line shift. The tricky part is measuring exactly the points, the start and end. That's what can throw you off. If needed, just keep going back and forth. It may take a few tries. As you can see, it definitely took me a few tries, and you'll eventually get to that perfect line spacing that you're looking for. But it will take trial and error and some math, but that is how laser offsets are done for all gantry style machines. Now we just walked through the 300 millimeter per second offset for this machine. Now keep in mind, all machines are going to be different in some manner. All belts are going to be different tensions, and over time, as that laser is being worked, the belt's going to stretch, and those offsets aren't going to be, they're not going to be adequate. So over time, just make sure that your engravings are up to par. If not, either tighten the belt or just keep doing those offset adjustments to make sure that you're always on top of just getting the best engravings possible.